Project Management Professional Training Session 14 Part A. Monitoring and controlling the scope, schedule, and resources. PMP exam objectives: what it really means. 4.1 Measure project performance. Measure project performance using appropriate tools and techniques in order to identify and quantify any variances and corrective actions. Here, it means that you must know the control and validate scope and control schedule and cost processes inside out, and their role in measuring project performance, and you must compare this performance with the baseline, requesting changes to stay the course and/or bring the project back on track. Also, understand how controlling resources is related to scope and controlling cost and schedule. 4.5 Review the issues log. Review the issues log, update it if necessary, and determine corrective actions by using appropriate tools and techniques in order to minimize the impact on the project. In this chapter, it belongs to the control resources process. 4.6 Capture, analyze, and manage lessons learned. Capture, analyze, and manage lessons learned using lessons learned management techniques in order to enable continuous improvement. Practically, it can and should be done in every monitoring and controlling process, but in this chapter, it refers to the control and validate scope, control schedule and cost, and control resources processes. High-quality projects deliver the promised product, service, or result within the planned budget, schedule, and scope. This is a very important and basic criterion of success: complete the project with complete scope, on schedule, and within budget. So, it should not come as a surprise when project performance is largely measured by making integrated measures of scope, schedule, and cost and comparing them to the scope, schedule, and cost baselines. So, the three fundamental project parameters are scope, schedule, and cost. You will see in this chapter that these three project parameters are intrinsically connected by a triangular relationship. Because the success of the project depends largely on how you manage this triangle, we call it the golden triangle. Because these parameters are intrinsically connected, so too are their monitoring and controlling. A parameter that is closely related to these parameters is resources. So, the core issue in this chapter is how to monitor and control the golden triangle and resources. In search of an answer, we will explore three avenues: the relationship between scope, schedule, and cost, monitoring and controlling scope, schedule, and cost, and monitoring and controlling resources. Controlling scope, schedule, and resources, big picture. In this chapter, we will discuss the monitoring and controlling of scope, schedule, and resources. Depending on the context, such as now, we use the term resources that includes cost. The corresponding processes are listed in Table 13.1, where high-level information about these processes is presented. Note that there are two monitoring and controlling processes corresponding to scope management. We will start by discussing controlling the project scope. Table 13.1. Processes covered in this chapter mapped to the knowledge. Controlling scope. Controlling the project scope is all about keeping a tab on the status of project scope and product scope, as well as managing changes to the scope baseline. While controlling the scope, you focus on the following tasks. Watch out for scope creep, determine whether it has happened and correct the situation. Scope creep refers to scope changes applied without processing them through the change control process. Process scope change requests through the integrated change control process for approval. Manage the implementation of scope changes after approval, as well as their impact across the project. Tip: in real life, scope creeps occur for various reasons. For example, perhaps a development engineer thought something was a cool feature to implement, or the customer spoke directly with the engineer to make a request for a minor additional feature, or various other similar situations. If scope creep has taken your project off track by affecting schedule, resources, cost, etc., you need to take corrective action to get the project back on track. You should also investigate how the scope creep happened and take steps to prevent it in the future, for example, by educating team members about the proper scope change process. Table 13.2. The control scope process: input, tools and techniques, and output. Input, tools and techniques. Output. 1. Project management plan. Scope baseline. Performance baseline. Scope management plan. Requirement management plan. Change management plan. Configuration management plan. 2. Work performance data. 3. Project documents. Requirement documentation. Requirements traceability. Matrix. Lessons learned register. 4. Organizational project assets. Data analysis. Variance analysis. Trend analysis. 1. Work performance. Information. 2. Change requests. 3. Project management plan. Updates. Scope management plan. Baselines, scope, schedule, cost, and performance. Measurement. 4. Project document updates. Requirement. Documentation. Requirements. Traceability matrix. Lessons learned register. Given the input, tools and techniques, and output shown in Table 13.2 for this process, the following is a brief account of how the output is generated from the input by using tools and techniques. 1. The scope baseline uses the WBS and the WBS dictionary to check out what the approved scope is. We have a scope management plan to tell us how to control the scope. 2. Compare the actual work performance data with the performance measurement baseline using variance analysis. 3. Compare the scope aspect of the work performance data with the scope baseline using variance analysis. 4. Use the trend analysis tool on project performance over time to determine if it's improving or getting worse. 5. Steps 2, 3, and 4 will generate two main output items. A. Work performance information that includes how the actual project scope performance is progressing compared to the scope baseline. B. This comparison may generate change requests to bring the project on track, e.g., requests to change scope, schedule, or cost baselines. 6. We will manage these changes using the change management plan and configuration management plan discussed in previous chapters. 7. Use requirement documentation to detect any requirement-related deviations from the scope baseline, and use a requirements traceability matrix to link the impact of any change to project objectives. 8. As you know from the previous chapter, all change requests are processed through the integrated change control process for approval, and only approved changes are implemented by using the direct and manage project work process. 9. In the control scope process, the input item work performance data includes information about received, approved, implemented, and validated change requests. This and change requests generated in this process will require some documents to be updated, such as the following. A. Scope baseline for scope change, and scope management plan to record how to manage those changes. B. Schedule baseline, cost baseline, and performance measurement baseline, because changes in the scope baseline or any of these baselines may trigger changes in the rest of the baselines in this set of baselines. C. In addition to these plan documents updates, some project documents may also need to be updated, including lessons learned register with effective scope control techniques, requirement documentation with additional, changed, and removed requirements, and the requirements traceability matrix to make it consistent with requirement documentation. Study Checkpoint 13.1. Q1. List some of the organizational process assets that will influence the control scope process. Q2. Why do you need the lessons learned register in the input of the control scope process? Scope monitoring and controlling ends with validating scope for acceptance of project deliverables. Validating the scope of project deliverables. Validating scope is the process of formally accepting the completed project deliverables, which have already been verified for their correctness using the control quality process. Before you hand over the project deliverables to the appropriate party mentioned in the project management plan, such as the customer or the sponsor, you need to validate with the party that the deliverables actually meet the planned scope. Caution! You should perform the validate scope process with the appropriate party even if the project is terminated, that is, ended before completion. In that case, you would verify and document the level and extent of the project and product scope that was completed. At the very least, it will help the close project process, e.g., for the record, project review, and lessons learned. Validating the scope of the project deliverables includes inspection, also called audits, product review, or a walkthrough, depending on the project and organization. The purpose is to ensure that all deliverables are completed as planned and therefore as expected. Table 13.3. The validate scope process: input, tools and techniques, and output. Input tools and techniques. Output. 1. Verified deliverables. 2. Work performance data. 3. Project management plan. Scope baseline. Scope management plan. Requirement management plan. 4. Project documents. Requirement documentation. Requirements traceability matrix. Lessons learned register. Quality reports. 1. Decision making. 2. Inspection. 1. Accepted deliverables. 2. Work performance. Information. 3. Change requests. 4. Project document. Updates. Requirement. Documentation. Requirements. Traceability matrix. Lessons learned. Register. The process used in validating the scope is formally called validate scope, and its input, tools and techniques, and output are given in Table 13.3. It may also be described in terms of the following steps. 1. Use the scope management plan to find out the planned procedure for accepting the deliverables. 2. Study the quality reports about the verified deliverables to find issues and recommendations. Also, information in the lessons learned register can be used to improve the Valida tie-in procedure in terms of efficiency and effectiveness. 3. Compare the requirements in the requirement documenta tie-in with the actual work performance data, which contains information on how much the actual work complies with the planned requirements. 4. Use the requirement management plan and requirements traceability matrix for information on how to validate the requirements. 5. Also, compare the actual result to the scope baseline. 6. Deviations and non-compliance found in steps 2, 3, and May 5 generate change requests, such as requests for defect repairs, and output. 7. Of course, in steps 2, 3, and 4, you are using an inspection technique that also creates the output item called work performance information, which records the validation status information, such as which deliverables have been accepted and which have not, and why. 8. Validated deliverables form the output item accepted deliverables and are handed over to the appropriate party, such as the customer or the sponsor, after being signed off on by them. 9. Update the affected documents, such as requirement documentation and requirements traceability matrix. See Study Checkpoint 13.2. Caution! Do not confuse scope validation with quality control or scope verification performed using quality control, which is primarily focused on checking the correctness of the deliverables and other quality requirements, whereas scope validation is about ensuring that the entire scope with the requirements have been implemented. Study Checkpoint 13.2. Q1. The Project Scope Statement, WBS, and WBS Dictionary are used to validate scope. Why are they in Table 13.3? Q2. The Verify Scope process belongs to which process group? Q3. From Table 13.3, you know that the project documents requirement documentation, requirements traceability matrix, and lessons learned register are updated during the validate scope process. Using your knowledge about these documents, what do you think they are updated within this process? Q4. Which process will be performed first, control quality or validate scope? As mentioned earlier, the project schedule depends on the project scope. So, controlling project scope and schedule are related. Once the schedule is developed and approved, as discussed in Chapter 5, it needs to be controlled throughout the life cycle of the project. Controlling the schedule. Schedule control has a three-pronged goal. 1. Monitor the status of the project to see if it's progressing according to the planned schedule, and, if it's not, 2. Take action, such as changing resources or changing schedule, and 3. Manage this change. As a project manager, you should be out in front of the project, performing the following tasks on a regular basis. Determine the current status of the project schedule. Influence the factors that generate schedule changes. Determine whether the project schedule has changed, for example, if some activities are running late. Manage the changes as they occur. You detect or measure a schedule change by comparing the project execution results, i.e., work performance data, against the schedule baseline. Both are major input items to the schedule control process, as shown in Table 13.4. Table 13.4. The control schedule process: input, tools and techniques, and output. Input, tools and techniques. Output. 1. Project management plan. Schedule management plan. Schedule baseline. Scope baseline. Performance measurement baseline. 2. Project documents. Project schedule. Schedule data. Project calendar. Resource calendars. Lessons learned. Register. 3. Work performance data. 4. Organizational project. Assets. 1. Earned value analysis. 2. Critical path method. 3. Variance analysis. 4. Iteration burndown chart. 5. What-if scenario analysis. 6. Project management. Information system. 7. Trend analysis. 8. Resource optimization. 9. Schedule compression. Leads and lags. Performance reviews. 1. Work performance. Information. 2. Schedule forecast. 3. Change requests. 4. Plan updates. Schedule management plan. Schedule baseline. Cost baseline. Performance measurement. Baseline. 5. Project document updates. Project schedule. Schedule data. Resource calendars. Basis of estimates. Assumptions log. Risk register. Lessons learned register. Performing the control schedule process. In the following, we will explain the control schedule process in the form of its main steps, getting the needed information. To control the project schedule, you need to know what to expect from the project, which is given in the schedule baseline, and you need to know how the project is actually performing, which can be found in the work performance data. These are the core input items need. Of course, as we are controlling the schedule, all the needed schedule-related items along with the schedule itself appear in the input column of Table 13.4. You will control the schedule as planned in the Schedule Management Plan, which also contains information about the usage of reserves and the allowed frequency of schedule updates. For other information about deliverables, assumptions, and constraints necessary for schedule control, we need the scope baseline. Generating the work performance information, measuring variance. In this process, we generate the schedule-related work performance information by comparing the schedule-related actual results in the work performance data against the schedule baseline. This comparison produces the variance of start and finish dates, and hence also the durations, of activities. The work performance information document has this information down to the work package level. This information is produced by using one or more of the following techniques. Earned value analysis. This technique is used to calculate the schedule variance, SV, and schedule performance index, SPI, and is discussed in detail in terms of cost in an upcoming chapter on cost management. In this process, you use these quantities to assess the variation from the schedule baseline variance analysis. Performing a bare-bones schedule variance analysis, this technique is crucial to schedule monitoring because it reveals the deviation of the actual start and finish dates from the planned start and finish dates of schedule activities. It also reveals the variations of actual versus planned durations and floats. It might suggest corrective actions to be taken to keep the project on track. Performance reviews. Performance reviews are simple reviews of project progress that compare the performance data with schedule baseline. These comparisons use start and end dates and percentages of completed and remaining work to analyze the variances. Project Management Information System. The included schedule software can be used to generate the schedule and schedule-related items, such as project network diagrams, bar charts, and histograms. Since it already has the schedule-related information, it is able to provide the schedule variance, SV, information and also forecast the effect of this variance on the schedule model going forward. Generating schedule forecast. Schedule forecasts are predictions of the future state of the project if it were to continue on the current path as defined by the current schedule-related work performance information. Forecasts are based on trends extracted from current and past information. The variance analysis technique and PMIS also include the ability to forecast the effect of a variance on the project's future. You can also use trend analysis techniques that compare the work performance data with the schedule baseline over time. One such technique is called an iteration burndown chart. The iteration burndown chart technique works by keeping track of the remaining project work over working days. A very simple example presented in Figure 13.1 illustrates this technique, where decreasing remaining work is plotted against the accumulating working days, called iteration days. The solid line represents the planned schedule in the baseline, which shows the project will be complete in 40 days. The bullet points in the figure represent the performance data from the project execution. The trend line drawn through these data points in the form of a broken line predicts that the project is on track to be completed in 47 days, a deviation or variance of 7 days. After we find out that the project has gone off track, by measuring the deviation in terms of variance, the question is how to get the project back on track, i.e., in alignment with the schedule baseline. Bringing project back on track, generating change requests and updates. Having measured the schedule variations from the schedule baseline, there are only two ways to get the project back on track. 1. Align the project with the schedule baseline without updating the baseline, and 2. Update the baseline, align the project with schedule baseline without updating the baseline. This can be done by using techniques already discussed while covering the schedule development process. The examples include resource optimization, schedule compression, lags and leads, and what-if scenario analysis. Update the schedule baseline. A schedule baseline update is an obvious way to align the project schedule with the schedule baseline. You can use trend lines and future forecasts as guides to update the baseline. Before the schedule baseline updates can be applied, change requests will need to be created, which must go through the standard approval process. Schedule change requests will also trigger other change requests, such as those to the cost baseline. Work performance information produced in this process may also create non-schedule-related change requests as well. As a result of these changes, documents listed in the output column of Table 13.4 may need to be updated. Caution! Since schedule variance on the critical or near-critical path directly impacts the project finish date, it mainly determines the project status. Therefore, the activities on these paths should be closely watched, even a short delay on the critical path can produce a bigger effect on the project end date than do bigger delays on non-critical paths. Tip: remember that corrective actions are not about going back and fixing past mistakes. Rather, they're about ensuring that future results match with the plan. You can do this by influencing the future results, such as expediting the execution or changing the plan. Study Checkpoint 13.3. Q1. Use your knowledge about the lessons learned register to figure out why we need it as input to the control schedule process. Q2. Knowing the control schedule process, make a list of organizational process assets that will influence this process. The need for project resources depends on the project schedule. So, controlling the project schedule and controlling resources are related. Once the resource management plan is developed and approved, as discussed in Chapter 6, the resources need to be controlled throughout the life cycle of the project. Controlling project resources. The project's physical resources are monitored and controlled using the control resources process, which, by monitoring the planned versus actually allocated resources, makes sure that the planned resources are made available to the project at the planned time. It tracks not only the shortage of resources, but also their surplus, and makes sure used resources are released in a timely manner. Table 13.5 presents the control resources process in terms of its input, tools and techniques, and output. In short, the central task of controlling physical resources is to keep the triangle of planned, allocated, and used resources synchronized, as illustrated in Figure 13.2. It means that all resources planned are allotted, and all allotted resources are being used. To make that happen, you will be monitoring the planned, allocated, and in-use resources, analyzing this resource data and creating change requests to take action, and making sure that those change requests are processed. In the process of doing all this, you will obviously be communicating with relevant resource stakeholders. Table 13.5. The control resources process: input, tools and techniques, and output. Input, tools and techniques. Output. 1. Project management plan. Resource management plan. 2. Project documents. Project team assignments. Project schedule. Physical resource assignments. Resource breakdown. Structure. Resource requirements. Issues log. Risk register. Lessons learned register. 3. Agreements. 4. Work performance data. 5. Organizational project assets. 1. Interpersonal and team skills. Influencing. Negotiations. 2. Problem solving. 3. Data analysis. Cost-benefit analysis. Performance reviews. Trend analysis. Alternatives analysis. 4. Project management. Information systems. 1. Work performance information. 2. Change requests. 3. Plan updates. Resource management plan. Schedule baseline. Cost baseline. 4. Updates to project documents. Physical resource assignments. Resource breakdown. Structure. Assumptions log. Risk register. Issues log. Lessons learned register. 5. Enterprise environmental factors.